Okay, so this is number 2 from your textbook portion of your review. So what rule can you use to determine from the graph of relation whether the relation is a function? So what they're referencing there is if you had the graph of a function, or a relation, sorry, you'd be checking whether the relation was a function using what we call the vertical line test. Okay, so we're going to graph each relation and determine whether determine which are functions. Okay, so that's meant to be a comma there. I think that's a textbook error. But so we're going to plot these points. So this is going to be question A. We're going to plot these points. Negative 2, 1. Negative 2, 1 is going to be here. 1, 1 is going to be here. 0, 0 is here. 1, negative 1. 1, negative 1's here. 1, negative 2 is here. And 2, negative 2 is going to be here. Okay, so just by looking at that right now, okay, I know right off the bat, if I'm applying my vertical line test, at x equals 1, I have multiple values of y. Okay, so for A, here we'll make a little running list here. A will be not a function. Okay, it fails the vertical line test. Not a function. There we go. Okay, question B. Question B is a line. Okay, so it's a line who, if I rewrote question B, we can rewrite it as y is equal to negative 3x plus 4. Okay, so we're going to graph that line. Again, maybe don't forget to label your xy axes the whole way too, okay? So it's a line who has, or a line that has a y-intercept of positive 4, 0, 4, and then a slope of negative 3. So we're going to go down 3, right 1, down 3, right 1. And we don't need to do any more. The opposite of going down and right would be up and left, up and left. Okay, so there's your line. That is specifically the line, close enough, of y is equal to negative 3x plus 4. Okay, you can see if we try to use our vertical line test, it passes every time. Okay, so that's going to be, b is going to be a function. There are no points along that graph where the line is touched twice by that vertical line test. Okay, question C. Question C should look a little familiar. Okay, that is actually a quadratic, right? Which is what we studied tons of last year in grade 10. Oops. Okay, it's a quadratic, the base graph. So what I'm going to do here, I'm going to graph the base graph, right? And then I'm going to apply some transformations to it. So we know the base graph points look like this. Okay, there's your base graph. That's y equals x squared. What's happened to that graph? Well, it looks like it's been translated to the right 2 units and up 4. So that's what I'm going to do, right? I'm going to translate it right 2, up 4. Okay? And then I know the rest of the points fall in the same spot. There's kind of like a little step pattern, right? So from the vertex, I can go out 2, up 4. Okay, to produce that graph, and then I know it's symmetrical about where the vertex is. Okay, so that's your new graph. But we know that all quadratics don't have any restrictions on their domain, and subsequently, if they don't have restrictions on their domain, they must not have any any restrictions on their y. And every time I substitute an x in, I get a unique y out. So that's by definition. You can combine the definition. It is a function, okay? But you can combine that definition with the fact that, quadratic passes the vertical line test. Okay? Question D. Question D, as we saw in like question A, question 1, is a circle. It's a circle with a radius of 1. Okay, so if we're to graph that again, we're going to have a circle of unit 1. Okay, so it's going to look like this. Okay, if I can move it, there we go. We know that circles are not functions, right? And that's because if I were to check this with the vertical line test anywhere, it's going to fail. It's going to touch it in 2 spots. Okay, so that is not a function. Okay, question E. E, you should recognize, and I'm not going to get into in this video how we produce that point, so you can go back and look at something else, but the points for this graph, okay, this is what we call the rational expression graph, or the rational graph. And what it does, it only has one major flaw in it, and it is when x equals 0, it doesn't exist. Okay. However, if I substitute negative values into there, I get negative outputs, right? So that must mean that anything I substitute in along here, this will be kind of what your graph looks like. Here, I'll draw a sketch of it. And then we can determine whether it's a function or a relation. Okay, so this is going to look like this. Sorry. Okay, something like this. This would be the graph of y equals 1 over x. Okay, it's called the rational. And to me, it looks like it passes the vertical line test everywhere. Okay, so it's a function. Okay, so E is, this is going to be a function. Okay, one more is going to be, question F there is the hook graph, okay, or the square root graph. It's going to look like this. Okay, make sure you call it the square root of x. Okay, the root x function. Okay, to me, that looks like it passes the vertical line test. Okay, so again, for question F, F is going to be a function.